Good morning, everyone. My name is Alejandro Vivas, and on behalf of the Department of Toxic Substances Control, I'd love to welcome you to today's workshop. It is our Hazardous Waste Management Report Workshop number 10, Modernization of Analytical Test Methods and Updates to Regulatory References. I'm going to go ahead and start by basically going over our language and captions options, as well as a couple of housekeeping items. First off, today on our Zoom platform, we have English and Spanish available. So you can go ahead and go down to your interpretation icon on the bottom right-hand banner of your Zoom application, and you can press the interpretation icon, and then you will have the option of using English or Spanish for this presentation. If you are phoning in, you can go ahead and go over to the More option and scroll down to Language Interpretation, and you will get the option of using English or Spanish. Next slide, please. Again, a couple housekeeping items. This morning, please use Google Chrome, Safari, or Firefox as your browser. It'll make things run a lot smoother. And we will be using the Q&A box as a Zoom feature to take our questions and answers. So please do not put your questions into the chat. It will be a lot easier for us to keep track of the questions that we have answered through the Q&A box. So please utilize that option. The camera and microphone features have been disabled for all the attendees, but please keep in mind this session is being recorded, as all of our other sessions have been recorded. So if you missed one of our workshops, feel free to go back onto our website and check out one of our past recordings. And also, we will be putting out a session evaluation so that you can let us know how we can improve. So please make sure to complete that at the end of this workshop. Next slide, please. So for further information, you can click on the QR code that's up on your screen, or go to our DTSC Hazardous Waste Management Plan website that you'll find up on the panel. You can join our e-list for updates. That way you will be apprised as to everything that's going on with us. And at the same time, you can email us at dtsc_hwplan@dtsc.ca.gov. Felice will go ahead and put that in the chat here in a second. And then next slide, please. So with that, I'm going to go ahead and turn things over to Ryan Dominguez. He's our supervising hazardous waste engineer, and he is going to go ahead and kick things off this morning.
Thanks, Alejandro. Good morning, everybody, and thanks once again for joining us. My name is Ryan Dominguez. I'm the supervisor for the Hazardous Waste Management Plan Unit. This is our 10th and final workshop of this workshop series. The series was developed to provide ongoing public education and encourage continued discussions during the development of the Hazardous Waste Management Plan. The topics and content that we've covered through these 10 workshops have been based on feedback that we've received over the last couple of years, and the workshops also present more detailed information on topics that were of high interest or that we received requests for additional information about. The workshops have also identified opportunities for planning and discussed considerations for recommendations. Alongside the workshops, we've continued to draft the draft plan based on feedback that we've received through the reporting period, during presenting out the report that we released in November 2023, and during the workshops that we've been holding here. On the screen, you can see just this was a part of the path. These were the last 4, and today is the last workshop of this series. Next slide, please. So we'd like to do a quick poll to see who's in the audience, if folks are familiar with our project, have read our plan or attended our workshops, and it helps us level set. So let's pop the poll up when we can. Two simple questions. Have you read our 2023 Hazardous Waste Management Report? And have you attended any of our previous workshops? You have 30 seconds or so, fill that out. Okay, why don't we close that out? There we go, there's some results. Okay, so we have 15 folks that responded, thank you. 11 have not read the report out of those 15, so about 70, a little over 70%. And it's about half and half that have attended our workshop previously and those that have not. I like to give some background on what our project is and where we're going. So in 2021, Senate Bill 158 was approved, and it made changes to Health and Safety Code 25135. The changes require the department to complete hazardous waste management reports that feed information into hazardous waste management plans. So in 2023, DTSC published the first hazardous waste management report. We're using the information in that report to draft the first hazardous waste management plan that's due by March 2025. So the draft plan will be presented to the Board of Environmental Safety for approval. The board will then hold 3 public hearings in 3 parts of the state to receive comments from the public on the draft plan. The board and the department will then consider the public comments and revise the draft plan as deemed appropriate when finalizing the plan. Then the cycle starts again. As we've talked about in previous workshops, this is an iterative process. It's going to take steps and it will take some time. Let's go to the next slide, please. As a reminder, you can access our report by going to our website. We do recommend that you read the full report and review the appendices. Links to the past workshops are also available on our website. And you can access the website here with the QR code. Next slide, please. During reporting, we identified 4 focus areas for planning. Today's presentation sits in the waste criteria focus area. As discussed in workshop number 6, which was about waste criteria, we talked about how DTSC is required to complete 3 different kinds of analyses for the hazardous waste management reports. And these 3 types of analyses inform for 3 different kinds of recommendations in the hazardous waste management plans. And this is related to the waste criteria requirements. So those 3 areas, so DTSC is required to assess whether there's additional hazardous chemical constituents of waste or additional hazardous properties of waste that should be accounted for in California's criteria. And DTSC is then to use that analysis to inform recommendations for additions to criteria. Secondly, DTSC is required to assess whether California's hazardous waste identification criteria provide necessary and effective protection. So DTSC is supposed to use that analysis to develop recommendations regarding wastes that are hazardous only in California, which may be managed under different standards while remaining protective. And lastly, DTSC is required to assess whether California's criteria for identifying hazardous waste are up to date with current science, technology, and testing methods. And we're using that analysis to inform recommendations for updates to our criteria that would reflect those advances. Now, the information in today's presentation is within this last requirement. If you go to the report and go to Appendix D, that appendix provides a table that compares California's hazardous waste criteria to the federal hazardous waste criteria and identifies where they're different. Now, today's presentation will provide information about the recommended updates for California's ignitability and reactivity criteria that came out of that assessment. Let's go next slide, please. In addition to the recommended updates that will be discussed today, I also want to highlight some additional opportunities for planning related to the hazardous waste criteria. Now, these are organized generally with the ones that we think will take the longest and moving towards ones that are closer to coming to fruition. Now, first, we're looking for chemicals or waste that pose emerging threats to human health and the environment. One example is a class of chemicals known as the per and polyfluorinated alkyl substances, also called PFAS. And these are sometimes referred to as forever chemicals. For these chemicals, the US EPA has started to do more regulation. And so our approach has been to prioritize the other facets of what we're required to evaluate while we wait and see what happens at the federal level. Next, we're also evaluating regulatory thresholds for the non-RCRA criteria. Now, we discussed these in more detail during our workshop number 6 that covered hazardous waste criteria. And lastly, we've begun an analysis of 2 analytical methods that are included in the toxicity criteria. These are the fish bioassay and the waste extraction test. For the fish bioassay, we're required to and have begun to look at alternative methods. And for the waste extraction test, or the WET, we are planning and are conducting further research into how representative the test may be. Now, for most of these, we've completed or nearly completed evaluations of their regulatory history. Now, this was an effort that was needed to begin to rebuild institutional knowledge that had been scattered over the years. There are some changes to our analytical testing methods that will be proposed via a rulemaking much sooner than these items will be. And Lubna will be discussing those today. We will open it up for questions at the end of the presentation. And I do want to ask that questions or comments relate to the material that's presented today. Oftentimes during waste criteria presentations, we receive questions or requests that are about very specific situations or about very specific wastes. Now, these types of questions usually require further research and are not the purpose of today's presentation. So with that, I will turn it over to Lubna Durrani.
Thanks, Ryan. With that, next slide, please. This is Lubna Durrani, and I'm the Senior Environmental Scientist with the Hazardous Waste Management Plan Unit. And I welcome you all for joining us today. Today's workshop is about the modernization of analytical test methods and updates to the regulatory references. So we will dive into some important updates and recommendations that are shaping the way we classify and manage hazardous waste. Throughout this session, we will be exploring some other relevant key topics in addition to these recommended updates. So by the end, you will have a clear picture of these updates and why they are essential for improving safety and environmental protection. Let's dive in and see what we will be covering today. In this session, we are going to discuss some important updates that the Department of Toxic Substances Control, called DTSC, is recommending to modernize its regulations. Many of our existing regulations date back to the 1970s, 80s, and 1990s, and haven't been updated frequently since then. As a result, certain sections have become old and need modifications, and some of them are even outdated. We are here to walk through the key standards for identifying hazardous waste, especially around ignitability and reactivity criteria, and we will also go over some recent federal updates that DTSC recommends to adopt. After we go over these points, we want to hear from you. Your feedback is essential to ensure these updates are practical and effective. So towards the end, we will open the floor for discussion to learn what you think about the changes. Here's what we will be covering today: sharing the updates and gathering your input. Here's our agenda for today's workshop. We will start with a brief introduction to hazardous waste criteria, focusing on what's important to know for identifying hazardous waste. Then, we will dive into the latest updates to these criteria and how important these modifications are. First concept to understand is the dynamics of California's hazardous waste management program, which is based on a dual system. This translates into a structure where both federal and state requirements play a role. At the federal level, the identification of a waste as hazardous is based on the criteria which is set by the US EPA and is classified as RCRA hazardous waste. California, as an authorized state, has its own criteria to identify certain types of waste, known as non-RCRA hazardous waste. So the non-RCRA hazardous waste are California-specific additional waste types that may not be covered under federal standards, but are recognized under California's regulations. Just a quick note. Throughout this presentation, I'll be using US EPA and federal interchangeably, since the US EPA is the agency that sets the rules and regulations at the federal level. So when I say federal, I'm referring to the US EPA, and when I say US EPA, it means we are talking about federal guidelines. Now that we have a foundation of how California's hazardous waste management system operates within this dual framework, we will look at the process for identifying hazardous waste and how it's implemented in practice. Let's talk about identification process of hazardous waste. It is a process of identification of hazardous waste through a fairly complex established criteria. This established criteria is a crucial part of hazardous waste management program to assure that waste is correctly identified and managed to protect the public health and the environment. Proper identification helps us know if a waste is hazardous waste and how to manage it properly. Today, we won't go into the details of this process since we have covered it in the past workshops, specifically the one which was conducted last month on October 22nd under the title of Understanding of Waste Identification Criteria. That was the workshop number 6 for this series. Links to these workshops are in the chat, so feel free to check them out if you had missed them before. As a quick recap, the hazardous waste identification process follows a set of questions. Is it a waste? And is it a hazardous waste? Now, for a waste to be hazardous waste, there are two ways that can happen. Either the waste can be on a list of hazardous waste, or if the waste exhibits a characteristic. For listed hazardous waste, US EPA has established 4 lists called as letter F, K, P, and U, each covering different types of hazardous waste. For instance, F-listed wastes are not specific to any one industry, like spent solvents, while K-listed wastes come from the specific industries, like chemical production. Now, P and U lists cover unused products that are now waste due to any specific reason. For instance, the product was never used before, but got expired, or etc. So in California, in addition to these 4 lists, we also have a 5th list, which is called M list. This includes certain mercury-containing items like old fluorescent bulbs when are discarded. So M-listed waste is recognized as hazardous waste only in California. Now the next question is, does it exhibit a characteristic of hazardous waste? When we say characteristics, it means that we refer to the properties of the waste that make them dangerous to human health and the environment when not managed properly. We will cover these characteristics in just a bit. So let's go to the final question, which is, are there any exclusions or exemptions? Now, for exclusions and exemptions, this is to share that federal hazardous waste criteria have several exclusions and exemptions, which may not necessarily be adopted by the state of California. For instance, federal identifies 44 exclusions, but California only adopted 8 exclusions into its regulations. So all of these questions are important as these help the waste generators to know if their waste must be managed as hazardous. So this is the time to talk about characteristics criteria. There are 4 characteristics at both California and federal level. And for each type of characteristic, the name reflects the specific dangerous property that the waste might show, such as first one is the ignitability characteristic, which can be described as a property of the waste to easily catch fire. Second one is the corrosivity characteristic of the waste that can corrode materials or damage skin. Third one is the reactivity characteristic of waste, which can explode or react violently. And the fourth one is the toxic characteristic of waste that can be poisonous or can cause cancer. These characteristics determine how the waste should be managed safely and appropriately. But for the purpose of this workshop, we will only focus on those characteristics among these 4 where DTSC is recommending modifications and updates. For instance, the characteristic of ignitability and reactivity. Historically, both federal and California standards for these characteristics were closely aligned in the beginning. This is important to know how these both characteristics have evolved over time at federal level, causing some differences between federal and state regulations while criteria remaining the same. As we just mentioned, there are some differences between federal and California regulations in the ignitability and reactivity criteria. Due to certain modifications made over the years, and DTSC now recommends adopting these updates to stay aligned with federal standards. While it's helpful to understand what these differences are, it's equally important to understand why they exist in the first place, especially given that the criteria originally started out quite similar. DTSC recommends adopt these updates with the aim to keep California in line with federal standards and to align with current scientific progress, especially considering some of this waste criteria was established nearly 40 years ago. To understand these changes, we will start by exploring why these differences exist in the criteria for ignitability and reactivity, and then take a closer look at what those differences are. So I have mentioned earlier that the criteria for ignitability and reactivity were once the same for both federal and California, because when these regulations were first established back in 1970s and 80s, California adopted the US EPA regulatory requirements exactly as they were for both of these criteria, which means in the past, both federal and state criteria for these 2 characteristics were identical. So for both ignitability and reactivity, the criteria used to be the same across the board. However, as the time went on, things began to shift. USEP criteria for both of these characteristics were evolved for certain subsections, which means that US EPA has modified these criteria several times to reflect current regulatory references, safety standards, and technological advancements. California, on the other hand, hasn't consistently adopted these federal updates, which has led to a divergence. Today, California's ignitability and reactivity criteria show some differences from those of the US EPA, even though they were initially identical. This lag means some references and requirements in California's regulations may not reflect the latest federal standards. Now, to explain the recommended modifications and updates, let's first establish a clear understanding of what these 2 characteristics actually stand for. For example, the first criteria we are going to look at today is the characteristic of ignitability, which is codified in the Title 22 of Section 66261.21 of California Code of Regulations. Now, the analogous criteria for federal regulations is codified in the Title 40 of Section 261.21 of the Code of Federal Regulations. This characteristic is important because ignitable waste carry a significant fire risk, which is a key factor in hazardous waste classification. The way we will go from here is first, we will build an understanding of what is the characteristic of ignitability. Then we will go over the regulatory requirements for ignitability, specifically focusing on how California state regulations differ from federal guidelines. Now, seeing these differences will help us understand why certain changes were made at the federal level and why it might be beneficial for California to consider adopting similar updates. Let's start with building our understanding of what ignitability characteristic is. The characteristic of ignitability is based on whether a waste could easily catch fire under certain conditions. In other words, they can ignite when exposed to heat, flames, or sparks. Improper handling or storage of ignitable waste can lead to fires and explosions. These wastes are dangerous because they can ignite even at low temperatures. Now, fire caused by ignitable waste can damage property, harm the environment, and even result in loss of life. Examples are many industrial materials such as paints, cleaners, solvents, and aerosol sprays, like hairsprays and cleaning sprays that we use every day. That may pose this risk when they are discarded but not managed properly. As we mentioned earlier, the criteria of ignitability characteristic is outlined in the Title 22 of Section 66 to 61.21. This section is subdivided into 4 subsections based on the type of waste it applies to. These 4 types are ignitability of liquids, non-liquids, compressed gases, and oxidizers. We have discussed these ignitable waste types in detail in one of our past workshops from the last month, which was specifically about waste criteria. Link to the workshop was already provided in the chat for your reference. So we will not go into more details in explaining them. However, we will look into some of these types with the specific perspective of discussing the US EPA modifications for federal regulations and with the aim to improve and align these standards in California regulations if appropriate. Which means that from now onward, we will go over these differences by looking at some examples of ignitability criteria to assess the DTSC recommendations to adopt US EPA updates. For instance, let's focus on the first waste type of ignitability, which is ignitability of liquids, where we will review the regulatory requirements of both at California and federal level for this waste type to define the differences existed between the two. As I just mentioned, we are using the example of ignitability for liquid waste. Here we see the regulatory requirements of the waste type in the state of California regulations represented in green. Also, let's do a side-by-side comparison by looking at the federal regulations for this subsection in blue. Now, there is a lot of text here, but we will focus on the major differences between these two frameworks, which are marked in red here. After all this previous discussion, now we can understand why these differences existing between the two set of regulations when once they were identical. To remind again, the reason these changes are found because federal had updated some of its criteria multiple times and we did not follow them always. So California is lagging behind. Now, moving forward, we will talk about these changes in detail. Our goal here is to understand these differences as we move further into each regulatory framework so we can assess the potential benefits of adopting these updates, which essentially will improve the safety of public health and the environment. To make things easier to understand, let's break down the main differences between California and federal regulations for this specific subsection, which is based on the highlighted text from previous slide. And now it's easy to focus on some key terms, which differently stated in federal regulations as compared to California regulatory text for ignitability of liquid waste. Key point to note in here is that the first two regulatory requirements are pertaining to alcohol exclusion, and the next 3 regulatory requirements are to determine the ignitability of liquid waste. Before we go further to get to these differences, we need to spend some time understanding these concepts. So these are 3 concepts that we will focus to get a better understanding of how they shape the criteria. First, we have aqueous solution. then alcohol exclusion, and finally is the flashpoint. We will look at each one step by step, starting with the first concept, aqueous solution. We will dive into what it means, why it's included in California's regulations, and how it differs from federal regulations. After that, we will see how it affects the alcohol exclusion rule. So let's get into it. Following our review, before we go further in defining the term aqueous solutions, let's see first how it's stated differently in California and federal regulations. The differences are highlighted in yellow. California regulations refer to aqueous solution, while federal regulations specify a water content of at least 50% water by weight. Now, what exactly is an aqueous solution? And why does it matter whether we specify it as a percentage or not? In the next part, we will dive into the context and explore how it impacts the criteria. It's important to understand what aqueous solution means in this context, as it's a key factor in meeting California's specific criteria pertaining to the alcohol exclusion. To understand the term aqueous solution, let's start by defining what a solution is. A solution is a homogeneous mixture where one substance called the solute dissolves into another substance called the solvent. Essentially, the solvent is the substance that does the dissolving, while the solute is the substance being dissolved. For example, when you add sugar to your tea, the sugar is the solute, and the solvent for this sweetened solution mixture is the tea. So, what is meant by calling a solution as an aqueous solution? Aqueous solution is a mixture where the solvent is water, meaning water is the main component that the other substances dissolve into. The word aqueous comes from the Latin word aqua, which simply means water. So in chemistry, anything described as aqueous involves water as a primary part. Now, why does this matter for classification of hazardous waste criteria? Well, knowing what counts as an aqueous solution is important because it impacts how materials are classified and tested, especially for things like ignitability. Originally, both federal and California regulations had the same idea of what an aqueous solution was. However, later, the federal modified the regulations. So now, in the updated federal regulations, the term aqueous solution is revised to be more specific by saying at least 50% water by weight. Basically, the US EPA made this change to clear things up. Instead of just using the vague term aqueous solution, the federal guidelines precisely says the percentage of water content for it to count. This new precise definition ties directly into the alcohol exclusion rule. Now, alcohol exclusion rule is the next concept that we will discuss in detail. So, the next concept, as I said, is alcohol exclusion. Based on this exclusion, if a liquid waste which has a mixture of water and alcohol but meets strict guidelines like a low enough alcohol concentration, it can be managed differently and doesn't need to be considered and labeled as ignitable hazardous waste. This rule lets certain qualified liquid waste containing specific alcohol and water content avoid being classified as ignitable. Let's discuss alcohol exclusion in more depth with the concept of refined definition of aqueous solution in federal regulations. To get a handle on alcohol exclusion, let's start with some basics. What does alcohol exclusion actually mean? Why do we even have it? And what kind of waste can qualify for this exclusion? We will also look at its purpose and how it works. This gives us a solid foundation to understand why the US EPA defined aqueous solution with a specific water percentage. It's all about making the alcohol exclusion clearer. So, what exactly is alcohol exclusion? As we mentioned earlier, it's a rule under both California and US EPA regulations that allows certain liquid waste that contains both alcohol and water to avoid being classified as ignitable hazardous waste. But not just any liquid with alcohol qualifies. there are specific criteria, like being water-based and staying under a certain alcohol percentage. As both California and federal rules include this exclusion, but the federal version was updated to replace aqueous solution with a liquid containing at least 50% water by weight. This makes it clearer to identify mostly water-based solutions that are generally low fire risks and help us figure out if exclusions apply more easily. Now that we know that what alcohol exclusion is, let's get into why the US EPA created it in the first place. Let's take a trip back to the 1980s. The US EPA wanted to align with the regulatory standards of US Department of Transportation, abbreviated as USDOT, which already excluded some alcohol water-based mixtures from being labeled as ignitable. The goal was to avoid over-regulating low-risk waste streams by not putting unnecessary restrictions on waste with little fire risk. It keeps the focus on real hazards. California adopted this rule too by staying consistent with federal practices at that time. Next, let's look what type of waste can actually qualify for this exclusion. Think about things like beverage alcohols, latex fans, or industrial ethyl alcohol mixtures, as long as they meet the water and alcohol content limits. These common waste types can fall under the exclusion umbrella if they check all the boxes. Lastly, why this exclusion useful, or what's its purpose? It actually has a couple of big benefits. First, it promotes sustainable practices. Alcohol that meet the criteria can be reclaimed or recycled, cutting down on hazardous waste disposal. And second, it reduces unnecessary regulations. If a waste stream is low risk, it doesn't need to go through the complex hazardous disposal processes, which supports environmental sustainability. However, even with this exclusion, waste generators need to make sure that their waste truly qualifies by accurately measuring the alcohol and water content. We just talked about how the federal regulations define the definition of aqueous solution to connect with the alcohol exclusion rule by specifying the water content as a percentage. Let's use this example to understand how the percentages of solvents and solute play a role here. When we talk about percentages, we are referring to the percentages of water content by weight and alcohol content by volume. Imagine this gray circle represents a liquid waste with alcohol. According to federal rules, for this waste to qualify for the alcohol exclusion, it needs to have at least 50% water by weight, meaning at least half of this mixture should be water, and the alcohol content should be less than 24% by volume. Now, this hypothetical example simplifies the exclusion rule, but in reality, there are few more things to consider when it comes to these percentages. For example, the concept of 50% water by weight and less than 24% alcohol by volume are two different ways of measurement in the mixture's content. But for this presentation, we will keep it simple and focus on the main idea. This distinction helps clarify how the same type of waste can be handled differently, depending on whether we follow federal or California's regulations. So, let's see another simpler way. How does this dynamics of specific water content matter in alcohol exclusion rule? This is another simplified version where we use a pie chart to explain this. This chart helps us illustrate how specifying the water content as the main solvent makes the alcohol exclusion rule much clearer. For example, if a liquid waste stream has less than 24% alcohol and at least 50% water, it can qualify as excluded from being classified as ignitable hazardous waste. Much clearer now? So now why it's important to set a clear percentage of water content? First, it reduces confusion. By specifying 50% water by weight, the regulations removes any guesswork, making it straightforward to see if a mixture meets the aqueous standard. Second, this clarification strengthens the alcohol exclusion rule for ignitable liquids. Under this rule, solutions with less than 24% alcohol by volume can be excluded from ignitable classification if they also meet at least the 50% water by weight requirement. So, by replacing the broad term aqueous with a clear 50% water by weight, it's easier for waste generators to know if this exclusion applies to their waste. With all this talk about aqueous solution versus 50% water by weight, it becomes clear why the US EPA's modifications for this rule help simplify the things, and this refined definition helps intensify most water-based solutions which tend to be lower in fire risks and make it easier to apply exclusions consistently. While California is still carrying the undefined term aqueous solution into its regulations. In summary, by tightening up the definition of aqueous solution and the updating alcohol exclusion rule, the US EPA ensured that only the appropriate waste streams can benefit. After understanding these two key concepts, now we are ready to dive in the next concept, which is about the flash point. Here is a list of questions that we will be looking at about this concept. First, we will build an understanding of the flash point to know what does it mean. Then we will look why flash point is considered for ignitability determination of liquids in the regulations. Later, we will spend some time on how flash point is determined by discussing closed cup testers and standardized test methods. And lastly, we will look into the differences between federal and California because of the federal modifications. As assessing these differences, which are resulted from the federal updates, will enable us to understand the consideration of adopting these updates. So, let's briefly understand what the term flashpoint refers to. Next slide, please. The flashpoint is the lowest temperature at which a liquid gives off enough vapor to form an ignitable mixture in the air. This temperature is a key parameter because it tells us how easily something can catch fire. The lower the flash point, the easier it is for the liquid to ignite. So, a liquid with a very low flash point is highly flammable, while one with a higher flash point is less likely to ignite at lower temperatures. This graph helps explain the concept of vapor concentration, that how vapor concentration impacts a liquid's ability to ignite. We see two important limits here. The lower flammability limit, which is abbreviated as LFL, and the upper flammability limit, UFL. The space in between is the flammable range, where the vapor concentration is just right for ignition. This is an example to show how the vapor concentration works pertaining to flash point. When we say a liquid waste has a flash point below 60 degrees Celsius or 140 degrees Fahrenheit, it means that once this liquid waste reaches that temperature, it can vaporize enough to enter this flammable range and potentially ignite. To sum up, if a liquid waste has a flash point below the regulatory limit, it's considered ignitable because it can easily reach this flammable range and pose a fire risk. Knowing these limits help us handle ignitable waste safely. To make this clearer, let's look at an example using the safety data sheet SDS for a chemical called anhydrous ethanol. For those who might not know, an SDS is a standardized document packed with essential safety information about chemicals. It's like a guide that tells us how to safely handle, store, and use a chemical, as well as the risk we need to be aware of. This SDS is sourced from an openly accessible document on Google, and on here, I want to point out the red circles showing the flash point of anhydrous ethanol. You can see that its flash point is 13.9 degrees Celsius or about 57 degrees Fahrenheit. Remember, for a substance to be classified as ignitable and potentially hazardous, it needs a flash point below 60 degrees Celsius or 140 degrees Fahrenheit. So based on this SDS, we can tell that anhydrous ethanol, in this case, is definitely flammable. This means that if it's heated, its vapors can easily form explosive mixtures in the air, especially around sources like sparks or open flames. All right. So this concludes our understanding of some key concepts, including aqueous solutions, alcohol exclusion, and flashpoint. Next, we will take a look at how flashpoints are measured using standardized test methods and specific instruments. We use specific testers like Martin's closed cup tester and Flash closed cup testers to get accurate readings. These devices are designed specifically to measure flashpoint. First, the liquid sample is sealed in a container, then gradually heated. This setup allows us to simulate real-world conditions like how a liquid fuel would behave in a sealed environment. Getting an accurate flashpoint reading is crucial for understanding a liquid's fire risk. It helps with regulatory compliance and makes sure we classify waste correctly to follow safety standards. Let's get a visual understanding of the closed cup testers used for determining flashpoint. Here you can see the main mechanics of the closed cup testers. This systematic diagram shows multiple parts of the instrument, including a heat source, which warms the sample to raise its temperature. Then there is a test cup, where we place the sample. A thermometer accurately monitors the temperature, and a stirrer keeps the liquid mixed, ensuring even heating. Let's take a closer look at the components of a closed cup tester through these photos of one of these instruments, such as Penske-Martin's closed cup tester. Here is a quick rundown. First is the tester cup, which is used to carry a sizable amount or sample into the closed container. Then there is a lid for the top cover, which closes the cup to ensure a closed environment. That's why these testers are called closed cup testers. The lid has a stirrer, which keeps the temperature even throughout. You can also see a thermometer there, which is to record the temperature of the sample when heated. After that, the lid goes over the cup, which holds the sample in it. Then this closed cup goes in the main setup to run the procedure. A small flame is introduced through an opening in the lid to test for ignition. So the sample is gradually heated at specific intervals and finally record the reading when it reached its flash point. As I mentioned earlier, this was a demonstration of Penske-Martin's closed cup tester, which was first created by a German scientist, Mr. Berthold Penske. So this instrument is named after its founder. This device was groundbreaking at that time because it allowed for precise measurement of a liquid's flash point. Now, by using a confined setup, the Penske-Martin tester simulates a real-world scenarios like those in storage tanks, making sure that the flash point readings are both reliable and reflective of actual risks. Where the flash point of the samples is recorded at the lowest temperature at which ignition occurs. This setup is very valuable because it gives us a realistic measurement of how a flammable liquid will behave under typical conditions and also help us determine flash point accurately. Now, let's look at the other instrument which is included in our regulations, and that's Flash closed cup tester. This is another device used to measure the flash point of liquids. It operates in the same manner as the Penske-Martin closed cup tester. However, there are some differences between the two, such as it operates with smaller sample sizes and faster testing times compared to the other one. Such as a small sample, about 2 ml of the liquid, is placed in a miniature closed cup. The sample is heated quickly and the temperature is closely monitored. A test flame is introduced at specific temperature intervals. And lastly, the flash point is determined as the lowest temperature at which the vapors ignite when exposed to the flame. The setup tester is valued for its efficiency and accuracy, making it useful for quick testing in laboratories and field settings. Now, after knowing about these two closed cup testers, which are used to determine flush point, it's important to understand that both California and federal regulations use these closed cup testers. These closed cup testers are the instruments used in specific analytical test methods. These methods are generally approved by ASTM, which are the American Society for Testing and Materials. However, overall, California is having three test methods you can see here highlighted in green, while federal is having five test methods, which are highlighted in blue boxes, in which federal added two additional ASTM standard in red font here. One using Penske and other using setup-flush closed cup testers. We will discuss further about these modifications later today in the updates section, so hold on your thoughts for it for now. All right, this concludes our discussion about the ignitability criteria and the differences highlighted between federal and California. So now that we have covered ignitability, let's move on to another important criteria, which is characteristic of reactivity. Just like with ignitability, there are some differences between federal and California regulations when it comes to reactivity. And DTS is recommending that California adopts the federal updates in this area as well. So before looking into these differences, let's briefly understand what the criteria of reactivity refers to. Reactivity is about identifying waste that could explode, react violently, or release toxic gases under certain conditions. Managing reactive waste correctly is critical because if mishandled, it can lead to dangerous accidents. Some reactive waste include cyanide or sulfide-bearing materials that can release toxic gases, explosive materials like munitions, and reactive chemicals like sodium metals, which can react dangerously with water. The criteria for reactivity are laid down in Title 22, Section 66261.23 of California Code of Regulations. Reactivity is one of the key hazardous waste criteria because of the high risk it presents if handled incorrectly. Most reactive waste are regulated under U.S. Department of Transportation System, abbreviated as USDOT rules for hazardous materials and explosives. Since no standardized tests exist for reactivity, the waste generator's knowledge is crucial for handling and classification. Therefore, having a solid understanding of this criteria helps us managing and disposing of reactive waste in ways that prevent harmful reactions. Now, after understanding reactivity, let's look at the differences between California and federal regulations in this criteria section. You can see here the regulations of California and federal, where the classification of explosives is referenced differently. The California regulations reference to the classification system of explosives as Class A or Class B, which is based on old US DOT regulations. Whereas federal is referencing a classification system using Division 1.1, 1.2, or 1.3 of explosives, which is based on the current US DOT system. This difference in classification system is because of the same reason, where US EPA has modified its regulations to reflect the new classification system, while California refers to the old classification system, which was based on the old US DOT regulations before 1990s. We will discuss more details about these differences in the updates section, which we will discuss momentarily. This is a time to share some updates on upcoming rulemaking processes, which means that along with our recommendations, we are also focusing on modifying few sections and updating some old or outdated criteria. So this is the last segment of this workshop, where the recent updates and recommendations in California's hazardous waste management system will be highlighted. And I will explain this set of updates in two ways. First set of updates are about the modernization of analytical test methods, and the second set of updates is about the modifications of the information which is either old or outdated. This is a great chance to learn about these important changes, their impacts on public health, and the efforts to keep California's regulations up to date. Let's discuss these updates one by one. First updates are the modernization of the analytical test methods, mainly in ignitability criteria to stay consistent with current US EPA regulatory standards and to remain up to date. For example, modernizing the analytical tests for flashpoint determination of liquid phase and for determination of ignitable compressed gases. And the second part of the updates also include modification of old or outdated information in some of the waste criteria sections which needs modification. For instance, in both ignitability and reactivity criteria, as we have mentioned earlier, there are some subsections which carry references to the old or obsolete information and needs to be updated. I will now briefly go over these updates to provide a clearer picture of the specific changes and their implications. These updates aim to bring the regulations in line with current scientific standards by revising the criteria sections that needs change. I will talk about these updates briefly for next few minutes. Let's start by looking at the updates aimed at the modernizing some of the analytical test methods used for ignitability criteria. This process of updating the regulations will go through a full rule-making procedure to make sure the regulations are current and up to date. All right. So first we will discuss the modernizing test methods for determining flash point. We have discussed the concept of flashpoint in detail earlier. For some background, most wastes that are classified as ignitable are liquids, and the main way to determine ignitability for these liquids is by measuring their flash point. To determine flash point, there are specific test methods that we have discussed earlier today. All these test methods are standardized, and these methods are generally approved by ASTM, which we already talked about, and those are the American Society for Testing and Materials. Here you can see the federal standards for testing flash points in ignitable liquids. If you want to know how old these standards are, then a key is that the last two digits on each method show the year it was published. So we can see these methods to the left are from the 1970s and 80s, and the two on the right are from 2018. Let's take a closer look at what these old versus new test methods actually mean. Here, you will see the images of instruments used to determine flash points. You guys might be able to recognize it. This is the setup flash close cup tester. The older setup is on the left, while the newer setup is on the right. Visually, we can see that the newer version uses updated instruments, which makes the testing procedures more efficient. Let's see what those updated instruments are. What's changed in the new test method is the switch to modern instruments like thermometers that no longer use mercury. These updated thermometers are now digital or electronic. This change means that mercury thermometers have been replaced, reducing environmental risks and simplifying lab work by easing accreditation requirements. Because California still requires the old test methods, labs in California have to use both old and new instruments to comply with both federal and state rules. This means they also need to keep up accreditation for both set of test methods, which can be a bit of a burden. Currently, California's criteria include ASTM standards from the 1970s and 80s, just like the old federal standards from that time. However, the US EPA has been gradually updating these standards while California hasn't adopted these changes yet. So, Where does this leave us? In California, we are still using the three older ASTM standards for measuring flash point in liquid waste, which are highlighted in green boxes here. Federal regulations, on the other hand, now include these three older test methods plus two newer ones, which are shown in blue here. In summary, the federal regulations now allow five test methods, where three old and two new test methods, while California is still sticking with the original three from the 1970s and 80s. DTSC recommends that, like the federal approach, California also adopts the two new test methods. This would allow California to retain the old standards but add the two updated and modernized test methods. These new methods offer benefits like electronic or digital thermometers, eliminating mercury use. Adopting them would streamline processes and keep our practices in line with the latest science. Now that we have covered the updates to the analytical test methods, let's move to another recommendation DTSC is proposing in the same subsection, which is clarifying the concept of an aqueous solution. To simplify this recommendation, let's look at the federal updated regulation for determining the ignitability of liquid waste. The US EPA made two key updates that we discussed earlier in detail. First, they clarified the alcohol exclusion by replacing the term aqueous solution with the clear requirements of at least 50% water by weight. Second, they updated the test methods. Since California doesn't specify a minimum water content, it simply calls it an as aqueous solution. We discuss in detail that this difference does matter because it provides clarity to the regulations. For instance, a solution might meet California's broader definition of an aqueous solution, but it wouldn't qualify under federal guidelines if it doesn't have at least 50% water by weight. DTSC is also recommending that California adopt both of these updates. So, along with adding the two new test methods, this is recommending to replace the term aqueous solution with a more specific term, at least 50% water by weight. This threshold ensures that only solutions that are mostly water-based qualify for the exclusion, which reduces fire risk by diluting the alcohol content. We have covered both of these changes in detail and both of these concepts in detail, and adopting them would streamline our regulations, keeping them aligned with federal standards and up to date with current science. Now that we have wrapped up the updates for ignitability of liquid waste, let's move on to the next topic, which is modifications to the regulations for ignitable compressed gases. These updates aim to align California's regulations with the latest changes from both the US EPA and US DOT. Just a quick reminder, US DOT stands for the US Department of Transportation, and you will hear me mention them a few more times as we go forward. As I mentioned, the next is modernization of the test methods for ignitable compressed gases, where there is an update needed to remove obsolete information pertaining to US DOT old regulations. California's existing criteria for ignitability of compressed gases still carry the references to the outdated test methods, which are no longer existent. These old ignitability determination test methods for compressed gases are already modified by US EPA by replacing them with a specified ASTM standard. US EPA modification was aimed to improve clarity, address outdated references, and align US EPA regulations with current US DOT requirements, thereby facilitating better understanding and implementation of the regulation. To understand this modification, let's look at the background information about this proposed modification. The existing California regulations use outdated cross-references of old US DOT regulations, which reference to the three old test methods, which are flame projection tests, the open and the closed drum apparatuses. to measure the ignitability of compressed gases. These test methods in the past were approved by the Bureau of Explosives, which is abbreviated as BOE, under USDOT. This is to share that all of these three test methods are no longer in use for determining of compressed gases. Even the BOE is not an approving entity under USDOT since several years, rather several decades. So, California's existing regulations still refer to the now obsolete BOE's methods, which are no longer valid or no longer in use. Let's see how existing regulatory requirements of USDOT are cross-referenced by US EPA. These are the existing criteria for ignitability determination of compressed gases in federal regulations, as the US EPA has already updated its regulations to align with the current USDOT's revised methods. US EPA updated regulations replaced the outdated references to the BOE or Bureau of Explosive with the language from the USDOT regulations that existed in 1980s when the RCRA regulations were first finalized. The criteria now indicates specific test methods for determining if a gas is compressed and ignitable based on its pressure and flammability limits. Therefore, the US EPA removed the outdated references to BOE methods and adopted the testing standards that USDOT now requires, which are ASTM standard E681-85 or any other equivalent methods approved by PHMSA, which is the abbreviation of the Associate Administrator, Pipeline, and Hazardous Material Safety Administration. To remain consistent, DTSC recommends updating the cross-references to the new USDOT approved methods, aligning navigation to the current test methods rather than those that no longer exist. All right, so let's move on to the next part. The second part of the updates focusing on revising outdated information within some of the waste criteria sections that require modification. Over time, certain references and regulatory details in the criteria have become outdated and no longer reflect current standards or practices. This is especially true in the sections related to ignitability and reactivity criteria, where some subsections still contain references to older or obsolete information that needs to be updated. One of the examples is the 4 additional notes at the end of ignitability criteria, which is codified in the Title 22 of California Code of Regulations, Section 66261.21, and these notes are outdated or unnecessary to understanding the regulations. These notes specifically talk about past organization structures and outdated regulatory references that are no longer relevant to current hazardous waste management system. For instance, Note 1 is about the Bureau of Explosive BOE test methods for the determination of ignitability of compressed gases. We have already discussed about this outdated information earlier. BOE is no longer operating entity, and all these 3 test methods are no longer existing test methods. Similarly, Notes 2 detail the functions of a defunct program by stating that it had ceased operation in 2005 and that this program, which is abbreviated as OHMT, have moved to another program under the USDOT. Let's look what information is provided by next note. Note 3 is also providing a similar information like Note 2, where it details about the program ceased operations in 2005 and also have moved to another program under the USDOT. It has been approximately 20 years that these changes have been occurred. Therefore, this historical information, which is provided by these additional notes, is no longer necessary to understanding the regulations. Finally, the Note 4 details the definition of an oxidizer and organic peroxide by stating specific regulatory references. This may be confusing because it references a USDOT regulation as if it existed in 1980s rather than its current form. The existing USDOT regulatory references no longer contain any definition for oxidizers and peroxides. Rather, these regulations are about the exceptions for class 4, which is a totally separate topic than what these references navigate us to. California still carrying the old text referencing to these old US DOT sections. US EPA already removed these additional notes, which carry outdated and unnecessary information, while California did not revise it yet. DTSC agrees with this modification and recommends following the US EPA's efforts to update and clarify the regulations, ensuring they are streamlined and are up to date by deleting or removing these additional notes. Another example of the modification is the old classification system of explosives, which is still referenced in California regulations for ignitability and reactivity criteria. This classification is based on several decades old US DOT standards. For instance, California regulations include the classification systems as a Class A explosives or Class B explosives. The terms Class A and Class B explosives came from the classification system for explosives used by US DOT before 1990s. Later, US DOT revised its classification system for explosives based on the United Nations recommendation on the transport of dangerous goods as a part of a final rule. This classification system has been modified by US DOT many years ago, where the new system replaced the use of explosives classes A and B with the classification codes of 1.1, 1.2, and 1.3. The US EPA has already updated its regulations to match these changes pertaining to the explosives current classification. This modification resulted in harmonized regulations by aligning the US EPA's regulations with the current US DOT's updated classification system and to prevent confusion. The corrected cross-references ensures the accuracy of the regulatory text and prevents the use of outdated terminologies. However, California is still having this old classification system, which was in use several decades ago. Like the US EPA, DTSC recommends to update the classification of explosives to reflect the new system of classification for both of these criteria. Let's look into another example, which is the last example for proposed updates. Here we are looking at the procedure for pH measurement using an electrometric test method. The purpose isn't to go through the entire protocol in detail, but instead to focus on the key method number, which you can see circled in red here as 9040C. Both California and federal regulations reference this pH measurement method to determine corrosivity levels based on high and low pH values. However, there is a technical error in the current California regulations where the test method is referenced simply as 9040 without the suffix letter C. The accurate reference should be 9040C, not 9040. This was once an error in federal standards as well, but the US EPA corrected it back in 2005. In summary, this update addresses a technical correction, which is a simple typo in the standard method number, but is an important one. Correcting 9040 to 9040C is essential to ensure California's regulations align with current federal standards, supporting consistency and accuracy in hazardous waste classification. Therefore, like the US EPA, DTSC also recommends making this correction to ensure alignment with current federal standards and to enhance accuracy in identifying hazardous waste. All right. Let's wrap up with a summary of the proposed modifications and updates DTSC is looking to adopt. These changes are focused on modernizing analytical test methods and updating outdated information to keep California standards current and aligned with federal regulations. Key updates include the recommendation of DTSC to modernize specific test methods as the addition of 2 new test methods. as well as clarification of the alcohol exclusion in ignitability of liquid waste subsection, and updates to standard for ignitable compressed gases. We are also planning to remove old BOE test methods and add a specific test method known as ASTM E681-85. Furthermore, we are looking to modify the outdated information such as deletion of additional nodes, updating classification system of explosives under both the ignitability and reactivity criteria. And finally, we are making a small but important technical correction, ensuring the pH measurement method correctly includes the C suffix, which is missing from the reference standard test method in the existing corrosivity criteria in California existing regulations. So, from adding new test methods to removing outdated nodes and even fixing small things like typos, we have covered each of these changes in detail today. Keep in mind, implementing these modifications will require a full rule-making process, which will take some time to complete. DTSC recommendation to modify some subsections on ignitability and reactivity criteria will ensure that California regulatory requirements are current, aligned with current federal standards, and are reflective of advancements in science and technology. With that, we conclude our workshop on modernizing analytical test methods and updating the regulatory references. Thank you for your attention. And now we would like to open the floor for any comments or feedback. Next slide, please. Again, thank you very much for being here. And now this is the time to get your feedback and comments to see what you think about these changes.
Great, thank you, Lubna. We actually have a couple of questions here in the Q&A. We have three as of now. So I'm going to go ahead and read those out. Again, folks, thanks for bearing with me while I read those. Just want to make sure that they are part of the transcript. Okay, so coming from an anonymous attendee, does DTSC plan on making ignitability standard read exactly the same as RCRA or still include some differences?
That's a great question. And the thought is to obtain or to copy the RCRA language or US EPA's language for ignitability section as is, and it's going to improve the language. And as we discussed earlier, a couple of things which are very important, we will adopt those updates. So yes, that's the plan. Thank you for asking.
Wonderful, thank you, Lubna. Coming from Martin Bermudez, hazardous waste laboratories have reported difficulty determining the ignitability of flammable solids consisting of absorbent and sorbed solvent. Has an evaluation of analytical methods for ignitability of solid materials been conducted?
I have.
Go ahead.
No, I haven't heard of those issues. I was reading that earlier, and I think one thing we could do is ask our lab if they've heard of any of those issues, and our waste evaluation and recycling unit.
Exactly, and if it's required, definitely we would be happy to look into that as well as a future.
Yeah.
Thank you for bringing that to our understanding.
From an anonymous attendee, will all the changes that DTSC is considering conform exactly to existing RCRA language?
It's kind of the similar question as first being asked, and answer is yes. For ignitability section, that's the plan, to adopt the RCRA language because of the modifications US EPA made, and we already talked a lot about this in this workshop, so yes, that's the plan.
From Marty Walters, not a question, but I want to thank you for the detailed presentation. This is the kind of deep dive that really helps build credibility in the California program and modernizing to conform to the national program. I learned a lot today. Thanks, Marty.
Thanks, Martin.
Thanks, Marty.
And it looks like we do have in the chat. Again, folks, please try to use the Q&A box, but I got a couple questions in the chat here. And this is coming from, I'm not exactly sure who this is coming from. I just have the initials MC. Can you provide any additional information regarding potential concepts that may be proposed as part of the HWMP relative to non-RCRA regulatory thresholds for lead and metals not regulated by the federal TCLP?
Thanks. I think that was from Michael Caprio. Yeah, a little bit, Mike. We've started the literature review on those. We're looking at the regulatory thresholds. So the STL, specifically the STLC, or the solubility threshold limit concentration, and the TTLC, the total threshold limit concentration, for lead and for some of the other non-RCRA metals. Copper, nickel, zinc are some of them. There's 9 total. So it relates to how the STLC was developed and how that was incorporating the drinking water standards that were in place when the STLC was developed. If you go back to our workshop 6, we talk about that a little bit in that workshop. It'd be a good reference. And then in addition, for the other additional metals, those are the metals, and it's in our report in section 8, where we identify those additional 9 metals and the non-RCRA metals. And what you'll see in there is that they're regulated primarily due to their toxicity to fish. Now we're taking both of these considerations for the threshold limits for lead and the non-RCRA metals, and going through that evaluation. At the same time, we're looking at the consideration. Okay, so they were developed with the drinking water standard in place, the time, and landfills at the time. And the protection of landfills afforded over time has greatly improved. We've talked about in previous workshops that when these standards were developed, landfills generally didn't have leachate collection and liners. They weren't really regulated closely at all. Over time, that's greatly improved. We also talked about this in detail in another one of our workshops. It was workshop 8 on modern landfill design. And so the protection of those landfills has actually increased and improved. And so those are some of the considerations that we're looking at as well. So it's kind of both the identification of a hazardous waste and with the thresholds, and then the management of.
All right, and one other question that is here in the Q&A box from Seth Heller. You touched on toxicity changes at the beginning of the presentation. Are there any planned modifications to definitions or testing methods?
For toxicity, not at this time.
Yes, those are under evaluation right now, and extensive assessment and evaluation is required. So all those listed items that we talked about in the beginning of this presentation, yes, we are looking into that, but it's a very early level of evaluation right now.
Yeah.
So
yeah.
So
the 2 in particular were the fish bioassay,
yes,
and the wet. Waste extraction test. Sorry, I'm using acronyms.
Wonderful, thank you. It looks like we do not have any more questions open in the Q&A box.
Okay.
So unless anyone has any more comments or questions, it looks like we'll be wrapping up here pretty shortly.
Great. And Felice just dropped it in the chat, but there is additional feedback. We've been doing a pre-workshop survey and a post-workshop survey. So please fill out the post-workshop survey. They've been very helpful for those that have been completing them. We've been trying to incorporate feedback that we've gotten about length, content, phrasing, and just general presentations, as well as additional questions that you may have or topics that are of interest. They have been very helpful. So for those that have filled it out, thank you very much. And for those that haven't, please do it. It's very helpful for us. Oh, and 2 more questions came in.
Yes, we have one from Seth Heller. Will we have a chance to comment of fish bioassay changes or wet test? When can we expect to see those change updates? Sorry.
I can take this. So as we said, it's under evaluation right now, and research takes time. So we don't have a set time period to answer to this question, but yes, those are under heavy research, and we are considering them. And there is efforts made, and we are still evaluating those. So to answer your question, we don't have a set time period that when, but yes, we are working on it.
Yeah, and let me add,
Yeah, please.
we're working on both of those. Resources have been somewhat limited. There's not a lot of people that are available to do this work, and part of the work that has been completed up to this point is becoming familiar with all of the information that kind of historical regulatory information for the fish bioassay. There's a number of alternatives that have, it's something that's being studied worldwide right now. And so there's a lot of information to go through. Currently, we are working to try and chart out some of those next steps. So Seth, stay tuned. If you have any questions or comments now, please submit them to us. We anticipate both of those taking some time, a couple of years is the general thought right now. They take time to review, and over that time period, we can report out and as updates or as we need to provide additional information.
All right, and then we have one final question coming from an anonymous attendee. When would we possibly see these changes going into effect?
For the changes that we're talking about right now, today, the ones that Lubna was presenting on, sometime soon, we're working on the reg package for it. And once that is finished, we can submit it. And my understanding, it's a 1 to 2 year process to get all of those in place and get those updates in. That's the general timeline as we understand it. But we're working on that reg package, and yeah, hopefully we'll hope to submit it sometime in the next year. And then it's the process from there. 1 to 2 years is our understanding.
Yeah, and let it happen.
Yeah.
Okay, and it looks like that concludes the question and answer portion of this webinar.
Okay. Great. Okay, and just since this is our final workshop, it's been a pleasure. Hopefully, those that have attended these before, I found them informative, interesting. Thank you, Marty, for that comment. That was our hope. That was the hope, and we hope we met that mark. Moving forward, we are due to submit a draft plan by March 1st to the board, and then the board will take that and have 3 public hearings in 3 various parts of the state. The details of that are still to come. They're being worked out. Once those hearings and once all the feedback comes in from there, the board and the department determine if any changes to the draft plan would be appropriate. So there's still more to come. Stay tuned for those those hearings next year, and those will be through the board. With that, I think we can wrap it. I don't see any additional questions or comments coming in. So, yeah, thanks everybody, and thanks for the interpreters online as always. Thank you for helping us out. And let's go ahead and close it out.